So getting back now to our second example, we're going to do pretty much the same thing. So again, I have a series circuit. Okay, and what I'm going to do is find V2 by first finding I2. Okay, and I know also that I2 is the same as I total, or the supply current, or the current coming out of the supply. And the way I find I total is by using Ohm's law. Okay, and we also know that R total, because this is a series circuit, we know that it's R1 plus R2. So in this case, R total is going to be 30 ohms. So I have 12 volts, I have I total, which I'm looking for, and I have 30 ohms. So I know that my total current is 0.4 amps. Okay, so now that I know that V2 equals I2 times R2. V2 is I2 because of this, and R2 is 20 ohms. So I know that V2 is 8 volts. Okay, again, because I have a series circuit, I know that V total equals V1 plus V2. So even though we're not asked, we know that 12 equals V1 plus 8 volts. So that means V1 is 4 volts. Okay. So what does that mean? Well, that means that I have a total of 12 volts, and I know that 4 volts, okay, is spent on R1. And I know that 8 volts are spent at R2 for my total of 12 volts. Okay, so let's go back to Tinkercad really quickly and let's see. So unfortunately, this is a 9-volt battery, but we should still get the same sort of proportion. So what I'm going to do, I'm going to stop my simulation, and what I'm going to do is I'm just going to change my R1 value from 3 to 10. I'm going to change my R2 value from 3 to 20. Now again, we're working with 9 volts instead of 12 in Tinkercad, but I just want to show you something really interesting, or maybe we can take a guess. If I know that R2 is twice the size of R1, what does that mean about voltage? Well, let's run the simulation. And what you might have guessed is that the voltage across this resistor is 3 volts, and the voltage across this resistor is 6 volts. In other words, the voltage across the second resistor is twice as much as the voltage across the first resistor, which is the same as the proportions of the resistances. So R2 is twice the size of R1, and R2 gets twice the voltage as R1. So I want to generalize that a bit in our notes by, instead of using a circuit with actual numbers, we're going to use a more general circuit. So let's talk about this general case. And let's keep in mind that this is a series circuit. So I'm going to write down the rules of a series circuit again. In electrical engineering, we do care about voltages just at very particular points in a circuit. And in this circuit, our point of interest is this one. And what that means is, okay, V out, so this is our ground, right? So V out is the voltage drop across this bottom resistor. V out is the same as V2. It's the same as the voltage across this resistor. So if I want to generalize V out, what V out is, I can do that in general terms by calling it or finding out what V2 is. Now, what I'll also notice is that we can write V2 in relation to our total voltage, and this is the way we do it. We start exactly where we did in our other two circuits. And we also know, based on this guy, okay, we also know that I2 equals I total. So what we can do now is instead of writing I total here, we can write I2. And now what I can do, let's use another color, is I can recognize that I have an expression for our total. Now let's keep in mind what we're trying to solve for here. What we're actually trying to solve for, we want to figure out what V out is. So let's do that. We know that V out is the same as V2. And we also know that V2 equals I2 times R2. So what we're going to do is we're going to write V out as I2 times R2. So now what I'm going to do is substitute an I2 okay, and we just have to write one more step. Oops. Okay, we know that V out equals, basically I'm just going to rearrange this formula. All right. Okay, so the take-home message, guys, is this one. Basically, what I can do is if I want to know my output voltage, and if I want to tweak my output voltage based on my values of R1 and R2, I can do that by recognizing that my output voltage is my supplied voltage, so my input voltage here, multiplied by R2 over R1 plus R2. So I can choose R1 and R2 accordingly. Okay, so I'm going to get you guys to take a minute, and I want you to figure this one out.